Wir starten mit dem ersten Format, das ist Lisa Falco. Sie ist Lead Consultant Data und AI bei Zühlke Engineering und sie hat den Titel What Industry Can Learn from Healthcare When Developing AI Solutions. Welcome on stage, Lisa.
I was very happy to see that you voted security as your top priority, because that will be very relevant for what I will talk to you about now. So you already heard from the previous speaker, AI will be the future for all of you to bring your companies to the next level. And it's been for a while. It's really been very, very hyped, AI. But then suddenly we started seeing other types of headlines. For instance, AI is sexistic. AI actually doesn't bring any help to anything. Or AI even sends the wrong people to jail. I mean, how could this happen? AI was supposed to save us all. So how did this happen, and how can you avoid that this happens to you? So when you develop machine learning, there's been a tendency recently over the last years to just have as much data as possible, and then you shove it all into this black box that gets bigger and bigger and bigger. The more, actually 90% of all research the last decade has been about making this black box even blacker by making the neural networks deeper and so on. And then in the end you get something out of it. If it looks good on your test set, you're happy and you proceed. This is really a way of the past, this blind application of AI, and not at all something that we have ever been allowed to do in medical AI. So how do we go about this in medical applications of AI, and what can you learn from this? So the first and most important thing when you develop a product for medical is that you understand the risk. You define the intended use of your device, and then you assign a risk to it. What are the consequences of failure? And then everything you do along in the future will then be depending on that risk. Just to give some example of my previous experiences, I was a part of a team developing this device for measuring glucose, a multi-sensor device that was going to turn into wearable. What are the consequences of a wrong glucose prediction? Well, that's being blind, having to amputate your limbs, or even die. That is a very high risk. On the other hand, another project I was working on was much nicer in terms of risk. That was a wearable with sensors to find when in the menstrual cycle you're the most fertile. What is the consequence of us failing there? Well, the woman doesn't get pregnant. It's not at all the same risk category. And that, of course, then influences all the choices you make along the line. And the risk management should really follow you all the way from the data to the black box and to the validation process. So if I go through just some guidelines on how to deal with this in your development, first of all, you need to really understand all the aspects of your data. And that means you need to develop on high quality labeled data, and you need to trust the label. You need to understand what the output should be. And you need to understand all the possible confounders that can come into your data. You are mostly on IoT, you're probably thinking hardware, but hardware is not your biggest problem. That's this lady over here, up there. Do you think she's drinking iced tea? Nah, she's probably drinking Bacardi Coke. And that has a huge impact on your signals, and you need to understand what's happening there. Also, you need to understand the bias. Are you developing your system on data that you will actually see in the real life? At Ava, for instance, we were developing our device for women that wanted to get pregnant. But then we wanted to develop a device for women who did not want to get pregnant. Do they behave the same way? If lifestyle is such an important factor, can you do this? Also, we developed this device in Europe on European women. Does this also apply then to American women? Also, it's very important that you understand your black box. the neural networks are getting deeper and deeper. So one way is not using them, using simpler models that you can actually directly understand. But you can also analyze the input or the features of your what's coming into your box. For instance, at AVA, we used neural networks, and then in our first neural network, we looked at, so what features are important of the one we're sending into our black box? In the beginning, actually, we realized it didn't care about the sensor signals at all. It was only using the day of the menstrual cycle. And that would make our device completely redundant. And it was also not what we wanted, of course. It's also the only way that you can assure fairness and transparency if you develop other applications. And it's the only way that you can generate actionable insights, which is very important for you in industry. If you want to predict failure, you want to know why that probable failure might happen. This is another example from my own experience, a risk score that we developed. We wanted to know what's the risk of a specific patient to develop post-operative delirium. Then, of course, you use the whole medical history of the patient, but then in the end, you need to understand what part of the patient's history is the determinant factors, because only if you understand this, you can actually act on it. On the validation, this is so important. You have to validate, not just on a part of your test set. You really need to validate what you're doing in real life, because it's very different. That data sets needs to be sufficiently large in your test set. And here there's a lot of things to learn from the medical area as well. In the clinical trials, there are very good guidelines on how big your test sets needs to be. And of course, it needs to be representative. And then a very common mistake is you need to choose a relevant metric. And something that always sounds very good is accuracy. I can assure you, please don't use accuracy. It's almost never a good way of measuring anything good. And especially, another advice, do never let your marketing department decide what is a good metric. Because once your metric is in the New York Times, there is no going back. And that can really cripple your development for a long time in the future. So why should you actually care about this? It's of course not only because it will give you a better product, it's actually going to come regulations for all AI. In April this year, AI published their intention to regulate AI all over, and it will be on a very similar basis as the one that we have already implemented for medical AI. So, what I want you to take with you from this talk are the cornerstones for medical AI. It's the intended use of your system, the risk management. You have to think of all the possible risks that it can englobe. And you need a really proper validation. And of course, what you can never get around is that you need to document all of it. And yes, if you have any questions, I would also like to mention that at Zühlke we offer also end-to-end solution covering data platforms all the way to cutting-edge AI and operationalization. So please feel free to reach out to me. And not only medical AI. Thank you.
Thank you very much, Lisa. So for me, one of the biggest questions is what is already done today in the medical part in real life, or is it only pilot projects where we start experimenting these scenarios?
No, it's coming more and more. There are a lot of things happening in radiology, for instance, to recognize tumor in CT scans. Also, AVA, we are actually on, I'm not working there anymore, but the AVA device is a medical device on the market, and so no, it's happening a lot. Yeah.
Is it more than the consumer health part, like these devices where you can control your own body or monitor your body? Or is it really also in, for example, emergency business where it's about life and death? So in which fields do you see more progress with AI?
It's much easier to do it in consumer health than it is in the hospitals. There's a quite high resistance among medical doctors to change their way of work, and they're often very happy with the workflows. But of course, a lot of things are happening in telemedicine now, especially due to COVID. It's really been accelerating a lot.
Last question, when listening to you, you have the impression that maybe doctors need to be data engineers in the future and vice versa. So this cross-disciplinary thinking, how important is it to make solutions come to real life?
I think it's incredibly important. You really need to understand the problems you're working on. It's been a big problem in the past that data scientists are only data scientists and they don't want to understand like the overall problem and the other way around for medical doctors. But I really see that the younger generations, it's going in this direction, and you cannot be siloed anymore, that's for sure.
So they should be cross-trained. Thank you very much for your insights, Lisa.
Thank you.
Okay.